So in this 23rd lecture, I'll discuss some problems based on K-map. So this is the first problem. It says simplify or minimize. I say simplify or minimize a Boolean expression f, which is a function of three variables a, b and c. And suppose I say it is equal to summation of say 2, 3, 5, 6 and 7. So it is a if you see, it is a three variable Boolean expression as a SOAP form, the sum of certain minterms. These are the decimal equivalents of some minterms. So now what I do, look at the solution. I frame a K-map. I frame a three variable K-map. How to frame a three variable K-map, that I have discussed with you. Three variables A, B and C. So these are the three variables. Suppose I make a rectangle and divide this into 2 to the power 3, that is 8 cells. Each cell corresponds to a minterm here. On one side it is AB and on the other side it is C here. And now I write down these terms here. I have told you how to write this. This is A bar, B bar. Then this is A bar, B. This is AB and this is AB bar. This is C bar and this is C. And I write the decimal equivalent here. This is 0, 1, 2, 3, 4, 5, 6 and 7 here. Now the next step I told you is to substitute a 1 on these positions, on these decimal equivalent positions in case of minterms when summation is here. So 2, 3, 5, 6 and 7. 2, 3, 5, 6 and 7. Now I have to minimize this. Now very first thing to minimize it, I can start from any one end, from any one of minterm, and remember that I search for the largest group. Remember that I search for largest group. That is, I search for an octet first, that is 2 to the power 3, then a quad, then pair. So if I start from this corner, if I start from this corner and I find that no octet is possible, no 8 ones are not there anywhere. Now I search for a quad, that is a group of 4. So here you have a group of 4 minterms here, group of 4 ones here. So this is my first group, I can say. This is the first group which I can search from this particular problem here. Second group, now I have covered these ones here. Now let's move to the next uncovered ones. These 4 ones has been covered. Now I look at this one. Now again I search with this one if any quad is possible. No quad is possible here. If you see, had it been a 1 here, yes, then a quad would have been possible. But since no quad possible, now I search for a pair and I found that yes, this pair is possible. And now suppose I name this. Suppose I name this as group number 1. Suppose I name this as my first group. And this is my second group. This group is my second group. This will be a reduced product and this will be a reduced product. So I can say that final expression f will be equal to, this final expression f will be equal to this first plus second. The resultant product of this first group and the resultant product of the second group. Now what is the resultant product of this? Look at this. I have dropped the projection on the vertical side. The common term is b. So f is equal to, I can say, it is equal to b, that is value of this first group after reduction. It is equal to b. Of course, look at this, the vertical, look at the horizontal side. Complete column has been covered, so its value is 1. b dot 1, I am not writing that one. Next, second, for this one, for this particular pair. Look at the vertical projection, common is a. So it is a dot, this side it is C, either for this or for this. So it is B dot AC, and this is my final answer. I hope that this is clear to you. Let's take a second problem. I take a next problem here. I say simplify or minimize. Simplify or minimize another function. Suppose I say f, which is of course this is by K-map. By K-map. I have missed it here. Simplify a function of a, b, c, a Boolean expression which is a function of a, b, c, and now let's take in terms of pos form. It is equal to pi of say 0, 1, 3 and 7. What will be the resultant of this? I am interested in this. What will be the value of this? Now look at this. It will be equal to, I can say that this function f a b c is equal to this much. I frame a k-map for this. First of all, I frame a k-map for again this 3 variable. So I make a 3 variable k-map for this. Just see, the 3 variable k-map for this will be, I make a rectangle and divide this into 2 to the power 3, that is 8 number of cells here. But this is for a max term. So on this side, I say it is a plus b. Let's write with a different pen. On this side, it is a plus b. And on this side, it is c. So now this value, I write here a plus b. Then this is a plus b bar. How to frame this? I have discussed this. This is a bar plus b bar. And this value will be a bar plus b. Of course, this is c and this is c bar. And now I write down the decimal equivalent of this here. This is 0, 1, decimal equivalent is same, 2, 3, 4, 5, 6 and 7. Now these are max terms. I told you that you substitute a 0 on these max term positions. So what I do, I substitute a 0 here at 0, 1, 3 and 7. Now I look for the largest group. I start from any one end. Suppose I start from this end. Quad is not possible. Had it been a 0 here, there would have been a quad. But since I don't have any, I don't search for any quad. So what I do, I make a pair. This is my first pair. Now these 2 zeros has been covered. Now I move to the next uncovered zeros, and so here it is. I start from this. Look at this. From here, what is possible? This pair is possible. Another pair, this pair is possible. And now I name this. Suppose I say that this is my group number 1 and this is the second group number 2. Now my value of final expression f, my final expression f, I can say final expression f will be 1 dot 2. This will be a sum and this will be a sum. So it is sum of product. It is a minimized sum of product that I will obtain from here. And what I obtain from here, look at this, f is equal to, what is the value of this? First group, see, it is a plus b, and this complete column is covered, so the value will be 0. So a plus b plus 0. I am not writing 0 here, so it will be simply a plus b. This is the value of this first group. Dot second group, this is my second group, and in the second group, if you see, I drop the projection on the vertical side. Common is b bar, so it is b bar, and from this side, if you see, it is c bar for this as well as c bar for this, so it is b bar plus c bar. I hope that this is clear to you, and this is my final answer. Now just see one more thing in this particular problem. One term that I'll define here, that is called a redundant group. What do you mean by redundant group? Just see, look at this particular problem. I'm redrawing this here. That is, you have this k-map. This k-map was given to you. I'm not writing a, b, c, d, all these things here. All I am doing is substituting these values. Here you have 0 at this position, this position, this position and this position. So I am substituting this 0 at these positions. 0, 0, 0 and 0. Now, what is there? That suppose somebody makes it like this. One group is this. Alright. And another two groups, I make it this way, which I have already done, considered. One group is this and one group is this. Now look at this. There are three groups here. This group covers these two zeros, this group covers these two zeros. If you look at this group, this particular group, it is again covering these two zeros which has already been covered. So this will maximize this size. I am not interested in the maximization of this. I am interested in the minimization of this. So such group, this particular group, such group is called a redundant group. This is called redundant group, and one should avoid this redundant group because it will maximize the function. It will introduce an extra term which I am not interested in at all. So I hope that this is clear to you. What do you mean by this redundant group? Now, one more thing, that if you look at this, all the problem is finished. This problem has finished over here at this point. This is a canonical SOAP form. If you look at this problem, this is a canonical SOAP form. This can be directly written in the canonical POS form also. That is, I can say, look at this, I am writing this again here. This f, which is a function of a, b, c, it is equal to summation 2, 3, 5, 6 and 7. This can be written down in the pi form. This is product, this is sum of minterms. This can be expressed as product of max terms also, but what will be the corresponding max terms is the remaining terms here. If you see that the remaining terms here are 0, 1 and 4. The remaining terms are 0, 1 and 4. This will result in the same, this will give you the same answer. Although of course in a different way, but in the same answer. Let's cross check it, what I am saying. Just try to understand this. That is, I am interested, if I want to solve this, how will I solve this? I'll frame a K-map for this. So I am framing a K-map for this, if you see. Let's frame a K-map for this. The K-map for this will be like this. I divide this into 8 cells on one side, but it is a max term, so I write here a plus b and here I write as c. Decimal equivalent is same, 0, 1, 2, 3, 4, 5, 6 and 7. And what I do, let's write here also. This will be a plus b. This is a plus b bar. Then a bar plus b bar. And this factor will be a bar plus b. This of course is c and this is c bar. Now what I do, I simply substitute a 0 on the max terms which are provided to me, remaining terms here. So I substitute a 0 at this position, I substitute a 0 at this position and 4 at 4. Now let me do the grouping of this. How grouping can be done? I start from any one corner. I start from this corner. What is possible? Octet is not octet or quad is not possible, so I look for a pair here. This is my first group. Second group, this is here, so I can fold it. I can cover this 0 n number of times until it is helping in making the biggest group. So suppose I say that this is my first group, this one. This is my first group and this is my second group. This folded group is my second group. So what will the value of this? If I say what is the value of this f? Final expression f will be 1.2. Sum product of sum. So what is the value of this one? I can say this f, if you find it, value of this f. First it will be a plus b. If you see from this side, it is a plus b. Although it is a plus b plus 0, I am not writing that 0 here, so it is a plus b from here. And what is the value of this particular group? Look at this. From the horizontal side it is b, which is common, and from vertical side it is c, so it is B plus C, and it is same as this, or we can prove it is same in this. I expand this. Okay, I'm expanding this, so it will be A dot B plus A dot C plus B dot B plus B dot C. I'm not writing the reasons, as you already know the reasons. This B dot B is equal to B. This B dot B is equal to B. So I'm writing this as B, and I'm writing this first. So this will be equal to B plus, then I'm writing this AB, then I'm writing this BC, and then I'm writing this AC. And you can see that this B is common from here. So I can say it is, this B is common from here. It will be 1 plus A plus C plus AC. And 1 plus A plus C is 1. 1 plus X is 1. I assume this as X. So I can say that this is equal to B plus AC. B plus AC, which is the same result as I obtained here. So this is equivalent to this because it results in the same. Similarly, this one also, same thing. I can write this particular term. I can write this as, this is in canonical pos form, or it is a product of max terms. I can represent this as a sum of min terms. But which min terms? Which are remaining here. That is 2, 4, 5 and 6. It is 2, 4, 5 and 6 here. I hope it is visible. 2, 4, 5, 6. And you can prove it that when you solve this, it will result in the same result. It will result in this same factor here, which I obtained in this part.